Hi, everybody. It's Friday the 5th, so it's time for me to answer some of the questions you guys had. And on the discussion board this week, most of the questions were regarding the first problem set, which I have here. A couple of people asked about the due date, so again, it's due Saturday the 13th, so just get it to me anytime before midnight on Saturday the 13th. But there were more questions on kind of how to do it. So what I thought I'd do is I'd kind of walk through the first couple questions to kind of show what kind of stuff I'm looking for. People ask about partial credit, so there is you will be able to get partial credit on these questions. So let's get started. So we'll navigate to the World Bank website, and we want to use the World Development Indicators database. Countries, we just want them all. And then series, we want Gini, which is a measure of inequality. We want wealth. So we want GDP per capita in constant $2010. And then finally, we want murder. Or sorry, I think it's homicide. Yeah, intentional homicides for 1,000 people. All right. And then time, we're just going to do 1 year. We just want 2010. All right. So we'll click apply changes. And it gives us something like this, right? So in the layout panel, you want to make sure that series is set to column so that your variables are the columns and your countries are the rows. And for time, you want that to be page because we only have 1 year. Okay, so then let's go ahead and download this. You can do it so I actually wrote the problem set so that you could do it in Microsoft Excel, but a lot of you are trying to get familiar with Stata, so we'll do it in Stata. So let's download it as a CSV format. It goes in your downloads folder, and you have to extract it. So you should have something that you can use to extract zip files, and it's going to be this first one here. Okay, so we'll go into Stata. We want to import the data as a CSV. All right. We don't want the weight and height data. We want this. Okay, you see everything looks good, so we'll hit OK. And it'll bring in our, okay, so let's re-import this. So hopefully you want your variables to have the correct names, and Stata will let you do that. So let's do that again. This first one here. Okay, and in our preview it's showing, okay, let's see if that, yes, we want to replace the data in memory. Okay, so we just have to do a little bit of upkeep. So let's delete this observation. Just do right click on, and we click on the 1 to select the whole row, data, drop selected data. Okay, and then we'll just rename these variables. So we'll call this year. Actually, we don't need either of these. So same way we selected a row by clicking on the 1 and then deleting it, we can actually, let's do this from the command line. We want to drop V2. We want to drop year because it's all the same year. We want to drop V2 because that's just telling us year. And we also want to drop V4, which is just country code variable that we don't need. Okay. All right, so we're left with this. All right, so V3 we're going to call, okay, rename V3 country, rename V5, that is, V5 is your Gini coefficient, we'll call it inequality. We will rename V6, old song. We'll rename V6 GDP, and we'll rename V7 as murder. I'll actually share it on Blackboard formatted like this. Okay, Because the other issue here is notice that there's a lot of red here. That means that Stata is storing these numbers as strings rather than as numbers. So we can make it stop doing that. So we want to, let's see, yes, we want to first drop if GDP is equal to this missing, and we also want to drop if murder is equal to this missing thing. Okay, so you can also just follow that syntax there. And then we want to string GDP. Okay, and so notice that once we put in that command, GDP goes from being red to black. So these, I don't know what those are doing here. Delete those observations again. I'll share this with you guys. Okay, so these, the problem is these two periods here. Stata sees those two periods and is thinking, oh, this is text set data, like this country variable over here, because there are non-numeric characters. So once we delete all the non-numeric characters, we can tell Stata, okay, stop reading this as a string and start reading it as a number. So let's do the same thing to murder. We're just going to say replace rather than generate a new variable. Okay. Now we've got our GDP and our murder variables. Inequality might be a little trickier. Let's replace inequality equals 1 dot just tells it data to fill that cell with a blank. If inequality it won't let us do that. So let's I forget this new laptop doesn't have a page up button. So on Stata, if you hit page up in the command line, it'll bring up the last command you sent, which is easy when you have errors like this. So let's just put in 999. Sorry, again. We want it as a string. So the reason it's saying type mismatch is because I'm putting in number variables when it's a string. Okay, now we can destring inequality. Yeah. Replace. All right. And now the last thing we need to do is now we want to replace inequality equals period or just missing if inequality equals 999. This is basically saying that the value of, or, and this is saying if it's actually equal to. So that's something to remember with Stata is 1 equals sign versus 2. Okay. So finally, this looks pretty, and I'll send you guys the pretty data sets. You don't have to do it yourself. The reason that you should know how to work through this, though, is with your final project, you might be working with unfamiliar data sets. You'll have to clean it like this. Okay, so then the next step is to generate some histograms. So let's use the graphic interface for this. So we want a histogram variable GDP, and again, it doesn't really matter whether you put frequency or density or relative frequency. It doesn't really matter for the purpose of this question. So it'll chug through that for a second. And this is the histogram you should get. And so you can either take a screenshot of this using your computer. I think it's Windows Shift S, or you can save as like a PNG and call it graph, and then throw that into your Word document. And again, if it asks for a graph and nothing else, you can just paste the graph. All right, the next thing is talking about natural logarithms. So this question has tripped some people up. So we want to create a variable equal to the natural logarithm of murder. So the way we can do that is we can do gen for generate. L murder equals ln for the natural logarithm of our murder variable. And it tells us that 3 missing values were generated. Okay, and if we go into our data, you can see that the missing values correspond pretty clearly to certain variables, and that has to do with a property of the natural logarithm. So I'm not going to give away what the answer. I mean, it's pretty obvious, but if you need to refresh your memory on properties of natural logarithms, but that's basically the issue I'm looking for you to point out in that question number 4. So we can also generate a natural logarithm variable for our GDP variable. And notice this time there are no missing values. I wonder what the difference is. Okay. But the reason why we use natural logarithms is let's make our histogram of GDP again. Okay, so this is just our straight GDP variable. And now let's make a histogram of log GDP. All right, and can I not display 2 graphs at the same time? All right, so if you remember, so the log GDP looks like this, kind of almost normally distributed, and a histogram of regular GDP. Histogram of regular GDP looks like this. All right, so we'll talk more about natural logarithms as the course goes on, but this is a good way to the reason I'm making you make these 2 graphs is so that you can visualize what a log transformation is doing. All right, because a log transformation is kind of a way of taking nonlinear data like this. This is obviously a very skewed histogram, and turning it into data that's more linear, more normally distributed. Okay, and then the rest of the questions are pretty much just the same thing. You have to make a scatter plot for one of them. So for that, you could do, you could use this, or you can actually just say scatter LGDP inequality, or maybe regular GDP. So yeah, either one. So you might notice that the countries with the lowest inequality tend to be richer countries, and poorer countries, the countries with a lot of inequality, tend to be somewhere in the middle. So you might say this is weak evidence for the Kuznets curve, but you can kind of use your own judgment on that. But yeah, that's pretty much it. Again, let me save this data set. But let me delete our log murder variable, because you'll make a better one, and I'll delete this. Okay, but this is basically just going to be a clean, we'll call this World Bank data homework 1. And I'll attach this to the problem set so that you guys can just download it and focus on the econometrics rather than making Stata do your bidding. Yeah, so that was the main brunt of the questions we got. There were a couple of interesting comments on randomized controlled trials. Someone brought up the Pepsi challenge, which I think is really interesting. That's a very famous RCT done in marketing, and marketing uses randomized controlled trials a lot. If you haven't heard of it, the idea behind the Pepsi challenge was, I think this is in the 80s, maybe the 90s. Pepsi, which is a soda company, wanted to show that they were better than their rival Coca-Cola, and so the way they did that was they brought people, they put them on camera, and they gave them basically a shot glass full of Pepsi and a shot glass full of Coke, and they were completely blind. You didn't know which was which. And on average, when people tried both, they preferred the one that was Pepsi, and it was a really big success. But what's interesting about that is, if you remember in the video on randomized controlled trials, we were talking about ways that randomized controlled trials can still conceal the truth, right? And we talked about scale effects, right? So you can have a issue with scale effects when you're doing a randomized controlled trial with on a really small scale, and then you take the results from that small trial and you blow it up to a really big scale, and the results fall apart. The Pepsi challenge is actually an example of scale effects, because what Coke found, because they were really angry that Pepsi was showing them up on television, was that people preferred the shot glass of Pepsi to the shot glass of Coke, but when you presented them with a full glass, like a full glass of Pepsi versus a full glass of Coke, people preferred the full glass of Coke. I think their theory was that Pepsi was sweeter, so you prefer like just a tiny shot of Pepsi is nice, but a whole glass of it is just too sweet. So that's just an interesting example. I'm glad you brought it up. That's an example of a randomized controlled trial that's really popular. It was on TV, but it's also an example of scale effects in action. So thanks for bringing that up. I think the other thing someone brought up is they said that they would be interested in a randomized controlled trial to study the effects of lobbying on political behavior. So basically, the way you could set that up, right, is you could have every member of Congress. You could say, okay, half of you can take as many donations from as many people as you want, and the other half you have to, you can't take any donations, and compare the way they vote. So that's an example of a randomized controlled trial we could learn a lot from, but we probably won't be able to run because Congress would probably be unwilling to, randomly allow half of its members to take donations and the other half not to. So we'll have to learn about ways that we can infer the effects of lobbying just from observational data. Okay, so I think that's pretty much it. I'll post this homework data. It'll be attached to the first problem set in the assignments folder. And I will talk to you on Monday to talk a little bit about some more statistical tools. We'll talk about covariance and correlation and stuff like that. All right, have a great weekend. Bye.